What is a geological disposal facility? How do you dispose of radioactive waste safely? And what does safe mean? The first person I have to convince that a GDF will be safe is myself. I'm Professor Lucy Bailey. I'm the Chief of Disposal Safety at Nuclear Waste Services. But ultimately, it's our independent regulators who will determine whether a GDF is safe. There are 3 key principles to disposing of radioactive waste safely in a GDF. The first is the need to isolate the waste, to keep the radioactivity away from people and our environment. Having done that, we need to contain it until the radioactivity has decayed to levels that won't cause any harm. And we need to do this in a way that is passively safe. That means we need to make sure a disposal facility will be safe for hundreds of thousands of years without needing any human interaction. A geological disposal facility will use a system of both natural and engineered barriers to isolate and contain the radioactivity. The geological barrier provides the isolation. A good host rock provides a stable environment through which fluids, groundwater or gas, can only move very slowly, if at all, and so take an extremely long time to return to the surface environment. We also have engineered barriers that work together with the natural barriers to contain the waste. A good natural comparison for the barriers that we will be using in our GDF is Cigar Lake. This is a large uranium ore deposit in Canada. Cigar Lake has been there for over 1 billion years, at a depth of about 430 metres below the surface, which is the sort of depth that we are considering for a GDF. Deep underground, there is a halo of clay-rich rock around the uranium ore that has prevented any trace of radioactivity reaching the surface. So this demonstrates that a few metres of clay around the uranium ore have enabled the radioactivity to be contained and not to be released to the surface. A GDF can only go ahead if there is a robust safety case. We've already talked about the long timescales that a GDF needs to be safe for. Over these long timescales, there will inevitably be uncertainties. And it's the role of the safety case to consider these uncertainties and to assess their impact on safety. So, for example, what if a waste container totally failed? We don't expect that could happen, but even if it did, our safety case shows that the geology and the engineered barriers will still provide the long-term safety. Or it's possible, in the deep future, that knowledge of a GDF may be lost. So we have to consider, however unlikely the possibility, that far into the future somebody could potentially drill into the GDF. So we're considering that too. We use all the scientific information available to identify and assess a whole range of different scenarios to optimize the design of our GDF in terms of safety. Safety is defined in terms of risk. And in the context of the GDF, that risk is related to the dose of radioactivity a person might experience. We are all of us every day exposed to a natural dose arising from just our environment. And that dose is about 2.7 millisieverts. Our independent regulators require that the maximum dose that should be allowed from a GDF is less than 1% of the natural background radiation that we all experience every day in the UK. So that's set at about 0.02 millisieverts a year. That's about the dose you'd get from 2 chest X-rays, or about a quarter of the dose you'd get from a single transatlantic flight. So we're talking about a very small additional dose from a GDF far below the level that could cause any health effect. We will not be permitted to construct a GDF unless we can demonstrate this to the satisfaction of our regulators. Around the world, many countries recognise that a GDF is the best solution for managing radioactive waste for the long term.